so I just jumped in and studied psychology. And when it came to the honours project at the end of my undergrad, that was the first time I really got an experience of what it is to do science and to ask questions about how the brain works and try and answer those questions. And at that point, I just fell in love with the process.
Hello and welcome back to today's Mug of Science episode, where we sit down with fellow scientists and have a casual discussion about everything science. My name is Ty Humphries, and we're here in West End today in Brisbane, and we're joined by UQ's Dr. Kelly Garner.
Hello.
How are you today?
I'm good. How are
I suppose I'm very good. I suppose we should start with a very important question. What's in your mug?
In my mug, there is a oat milk piccolo, which is the optimal ratio of milk to espresso.
Perfect.
I find.
Ideal
Yes.
ratios. Okay. So I guess we should start with asking, tell us about your background of how you got into science or outside science. What do you do?
My background. Well, how I got into science, it was very fortuitous actually. I started out in my undergrad studies actually doing English literature and film. And I was enjoying the course, but realised that perhaps the things that it offered long term were not for me. So then looked through my university prospectus and saw a psychology degree was available at my campus, and had always been intrigued, so I just jumped in and studied psychology. And when it came to the honours project at the end of my undergrad, that was the first time I really got an experience of what it is to do science and to ask questions about how the brain works and try and answer those questions. And at that point, I just fell in love with the process and stayed with it ever since. So yeah, and by way of background, so I live in West End in Brisbane, and yeah, when I'm not doing science, I tend to be outside as much as possible. I enjoy rock climbing, so I'll be up mountains every opportunity. Yep, and love cinema, love music, and piccolo coffee.
And coffees.
So, yeah.
Yep. Do you do a lot of rock climbing out at Kangaroo Point?
We do, yeah, I go to Kangaroo Point a lot. Do you climb? Or?
No, but I've walked along.
Yeah.
I've walked along there and seen them all climbing up it, and it's just hardcore. Like I can't imagine doing anything bigger than that, and that's just it blows my mind.
Yes, we're very lucky in Brisbane in that you can walk to an outdoor cliff and climb. But we're very unlucky in Brisbane in that that cliff has a lot of ledges and the bolts are really far in between. So like KV is like the baptism of fire of climbing in the local area. If you're doing sport climbing, yeah. If you can climb there, you can climb anywhere basically.
I have seen a friend just before he latched onto the next one. I'm not sure if that's what you call it. He fell off. And it was the very first one that he was connected to. So it was quite a bit of a drop all the way back down.
Yeah. He took a whipper in climbing parlance.
A whipper.
Yeah.
Okay. So have you lived in Brisbane your whole life?
No, I'm actually from the UK.
Oh. Okay.
But I've been here for 10 years.
Yeah.
And the region where I'm from in the UK, we also go up at the end of our sentences, as is the Queensland vernacular.
So the assimilation of the accents was very easy.
Yeah, so
I'd
I've
say I can
picked
see,
up
yeah,
a
I can't
twang.
say I picked up much of a British accent.
Yes.
10 years in Brisbane might have changed that a little bit.
That's what my family say on every Skype call as well.
Yeah. But do you change it when you talk to them too? Does it kind of revert a bit back?
Yeah, so actually when I'm back in the UK and near my family, the region I come from is very regional. So we talk a bit like farmers.
Oh, okay.
And so I'll slip into that when I get back home.
Oh, okay. Let's maybe talk a bit about your research, about what you do in the lab, or you call it a lab?
Yeah, we do lab work.
Yep.
Yeah.
Let's talk about what you do there.
What I do on a day-to-day basis, you mean?
Yep.
So I largely, I do a few things. The mainstay of my day is I design and carry out experiments that are designed to ask questions about the human brain and how it works. And so that can involve like coming up with a task that I think represents a concept under study. And then I ask people to perform that task, and I'll analyze their behavior. Yeah, so I experiment on humans. The other thing we do is sometimes I'll take you to the MRI scanner and I'll take pictures of your brain while you're doing these tasks. So then I can look at your brain activity. And so MRI is really good for looking at where in the brain things are happening. The other thing I sometimes do is I'll take you to an EEG or an MEG system, and that involves, with EEG for example, we put electrodes on your head, and then we record the electrical activity of your brain while you do a task. And so that is really good for telling us when in time things are happening in your brain. And so by combining those things, I will then also seek to develop models of how the brain could be completing like a given function, such as deciding where to look next. And I'll use those to predict the data that I collected from you, and then I'll see, which models win. And that will hopefully tell us something about how the brain does something. Yeah.
Oh, fantastic. And so what kind of people do you work with? Are they old people, young people?
Largely I work with in psychology or neuroscience research that works with humans. We have heaps of undergraduate students available to us.
Yep.
So we know a lot about the healthy brain of 22 to 26-year-olds. Have done a little bit of work with other patient groups. So, I've done some work with people who experience autism or people who experience ADHD. So yeah, it's a whole range of people, but largely undergraduate students.
Right, it's a bit like clinical trials for a drug. Your first phase is your students and backpackers, the people that do anything for a little bit of money.
Exactly. Their brain is very well studied. We know a lot about it.
It's a wonderful cohort, especially at UQ.
Yeah.
So where has your research taken you across Australia?
Where has my research taken me? That's a great question. It's taking me all around Australia. So how I wound up to be in Australia actually is I was backpacking. I was one of the cohort of backpackers.
Okay. Did you sign up for any studies? Were you backpacking?
I didn't sign up for any studies, but I did miss research. And then I knew I was coming to Brisbane to visit friends, and the idea was to stay for 6 months. And then I emailed some people at UQ ahead of time to see if I could pick up some research work while I was here and get some experience. And then the day after my flight landed, I got an email saying you should apply for this specific job. So I applied for that job 2 days later. I got offered an interview that day, had the interview 2 days later, and they offered me a year's contract on the same day. So I was like, okay, I'll stay in Brisbane a year.
If you twist my arm, I'll stay.
Yeah, it was so fortuitous. And then it turned out that research team were amazing. And so I then stayed with them to do my PhD. And have only been back to the UK for 2 years in that time. So that kept me in Brisbane. But I've also, I've been very lucky to be able to go meet people, for example, in Newcastle and in Tasmania and Sydney and Melbourne, and, share my work there and hear about people's work in those locations as well. So yeah, it's been, the Australian neuroscientist community is a really good, friendly place to be. Yeah.
Okay, so my next question would be, if you weren't in neuroscience, what kind of science would you want to jump into? Or what other sciences are you interested in?
Wow. Let's see. That's a great question. There's so many sciences in my brain right now going, pick me, pick me. So I would definitely love to learn more about physics. I think that's a beautiful science to and what you can apply with what you understand in physics is amazing, because you can apply it to like the infinitesimally small and also to the entire universe. So that would definitely be up there. And then part of my job is understanding and using statistics, which I really enjoy. I find a fascinating element of my job. So I think, I don't know if it's strictly classed as a science, but I would definitely spend more time learning more about probability and statistics.
I think statistics is a really important. I don't know if it's a science itself. Would you call it more of a tool to perform science? Or is there...
We definitely use statistics as a tool in science. So we have these assumptions. So we formulate our question about how we wonder how the world is working, and then we come up with our test, which should be able to tell us whether our question or assumption holds any weight. And then we apply statistical tests that have assumptions that underlie them to the numbers we have to tell us whether our test was useful or successful. And so it's a tool, but it's also the construction of those tests. They have like a way of thinking or a philosophical underpinning behind them. So I would also say that it is also a philosophical approach to what causality means, really, and how causality would show up in numbers. Yeah.
Fantastic. So tell me about the research that you do and the work that you do.
So my research covers 3 broad topics. So the first of the 3 that I'll talk about is I look at how learning and expectation influences visual information processing. And so what I mean by that is, at any given moment we're bombarded with sensory information, and we have this experience where we could only report on 1 or 2 things at a time. So for example, if I told you to tell me what that plant was over there, exactly, you have to go look at it, right? Like, it's in your field, but you don't have the reportable information about it. So it seems at some point there's a limitation in how much sensory information we can take in, which then suggests that there must be some competition that's going on in your brain that determines where you're going to look next. So we know that there's a few systems that arbitrate or like compete in this environment. So one like situation I like to think of is, you could imagine if you're going out to buy lunch, and you walk into a deli. Now you have the goal of buying lunch, so you're gonna aim to look at like, the pastries and the salads and whatnot. But you also have, you've had like pleasurable experiences in your life, right? And so the cakes that are on the left, you don't want them for lunch, but they're going to compete for your eye movement because they're delicious. And so there's part of your system that knows that it wants to do that again, and it's going to drive you to look over there. And then, for example, you could be someone who bakes bread every day or buys bread every day. And so you have this very ingrained behavior that you do every day. So you start looking over at like the flour and the yeast that would allow you to do that. So wherever you are, you have these multiple systems that are competing to control where you look next, and that has subsequent impacts for your behavior. And so what I really try and understand is what are the actual parts of the brain that support those different systems in that competition, and then like how does the competition actually occur? Because at some point, you've got information about sorry, I had a boo boo boo.
My laptop just went flat, but we still got it.
We're still good? Okay. So the information about cake is very different to the information about salad, but at some point there has to be a common currency so that a competition can be borne out and won. So trying to understand the computations that the brain does to be able to instantiate that is another focus. And then I'm really trying to understand how individuals and why individuals vary in their response to those kinds of environments.
So that was the first prong.
That was.
What's your second prong?
So the second prong, and this is really what I started my PhD in, was I look at how the brain changes how it performs a task when that task is very well practiced, and how that allows you to multitask. And so, a good example of this is when you first learn to drive a car. It's very effortful. You have to focus entirely on that process. However, when you've been driving for a car for years, for better or worse, you can start like playing with the radio at the same time, or talking to your mother on the phone, or to an extent, it becomes autonomous. And so I really try and understand how the brain's representation of that task changed, and what it is that changed that allowed you to start doing other tasks at the same time.
All right, okay. And what about your third prong? That's your statistics areas.
Yeah, so this is a more recent prong, but I'm really excited about it. So it's known as meta science. So this is, we do science about how we do science. And it's close to my heart because we, in science have had a lot of discussion over the past, 5 years or so at least, about how robust is our research, how reproducible is our research. And there have been some, questions about how reproducible different areas are. And what I mean by reproducible is, if I do an experiment, if you read my paper and did an experiment like in another lab or another country, how likely is it you'll find the same result that I did? And that's obviously really important because we're trying to describe truths about the universe. And so it's really important that the work we produce is reproducible, or the theories we develop are based on reproducible work. And so what I and a few excellent friends and colleagues of mine have started doing is we've started asking a question about how, well, if you, one thing we all do is we apply statistical tests as rules, and those tests carry assumptions about, for example, most people can only collect like 20 odd samples. And so what we do is we've developed these tests that assume that our data are representative of what it would look like if we collected 1 million samples. But that's an assumption in many cases. We don't know for sure that our data would actually look like our assumed distribution if we actually collected 1 million samples. And so what we've started doing is, because we're very fortunate, we live in an age where we have great computing power, and we have access and ability to talk to lots of different labs and collect lots of data. We're actually finding ways to collect and simulate millions of samples. And so we can identify cases where the assumptions hold true and where they don't. And that can also be meaningful for about what it is you're looking at in the first place, but also it can help us improve the statistical tools that we have, which will then hopefully improve the reproducibility of the work that we do.
So I guess this is a question that's been playing on my mind. You mentioned multitasking.
Yeah.
Now, I'm told a lot by my partner that because I'm a man, I can't multitask. Is there any kind of truth in that?
So actually, I haven't personally looked into the gender multitasking question myself, but I do have some colleagues who have, and their data is very interesting. So one thing that's been shown is that there is a propensity for a higher probability of males to multitask less often and do more things one at a time, while there's a propensity for more females to do tasks as a multitask. But when you get them to do tasks the same way, they perform exactly the same.
Okay.
So it is just a strategic choice. And why that strategic choice becomes biased across gender, I think, remains to be answered. But it doesn't seem to be like an inherent difference. And then I have another colleague who ran a study at, it was a big citizen science study, so it was at the Science Museum in Melbourne, and everyone from the community can come in and engage with her multitasking task and answer questions about it. And what she was interested in is, do people have insight to how good they are at multitasking? And so it turns out that male and female genders showed comparable multitasking behaviour and performance, but females had stronger awareness at the decrement of their performance in multitasking. So there seemed to be this difference in how multitasking performance was assessed and evaluated, or self-multitasking performance was assessed and evaluated within the male and female genders. Yeah.
Right, okay. Well, there's a great answer to a great argument starter for whenever my partner says that to me again. Fantastic.
Exactly. You can go home and multitask.
Maybe I'll just play this interview back for her and be like, listen to this bit. There you go. Oh, well.
Sorry.
Perfect. Thank you, Kelly, for sitting down with me. We ask all our interviewees this at the end of their mug interview. So to you, finish the sentence. To me, a scientist is someone who...
Ooh. To me, a scientist is someone who is awed when it's revealed that there is some order to the chaos of the universe.
Fantastic. That's a great answer.
I had
by randomness.
awed by
Chaos.
finding order in the seeming chaos. Yeah.
Thank you, Kelly.
You're welcome. Thank you.
For the rest of your day.
Likewise.